Good morning, seventh grade. Let's go ahead and let's get started with our part 2 of the test prep review. So again, I hope you watched video 1 that covered questions 1 through 5. So we went through, and if you did your assignment from last Thursday, you should have all the answers and how to work out all the problems from the first page of the test prep. Hopefully you went back through and you corrected your answers as well. Today we're going to finish out this test prep. We're going to do the last couple of problems. So we're going to do the back page numbers 6 through 9. Guys, write these down. Make sure you know how to solve these questions because your test that you take tomorrow is going to be very similar. I cannot stress that enough. It's going to be very similar to this test prep. Let's go ahead and let's get started. So number 6. In a game of chance, players spin the pointer of a spinner with 6 equal-sized sections. So here's our spinner here on the screen. Hopefully you can kind of locate where my mouse is and kind of follow along with me as we go through this. So I've got this spinner and there's 6 sections, and I've got sections 1, 4, 1, 2, 1, and 3. My first question is sample space. And if you remember from my video yesterday, you should remember that the sample space is all of my possible outcomes, and they can repeat. So even though I've got the number 1 3 different times, I'm still going to list off 1 3 different times in my sample space because I could land on any of these ones when I spin this spinner. So to answer the first part, my sample space, brackets or parentheses, my sample space, and list them in order from least to greatest. It's going to be 1, 1, 1, and then 2, 3, 4. And all I did is I looked at my spinner, looked at all my options, and then I just copied those straight down. Another thing to keep note of, notice guys, in number 6 here, it says player spins the pointer with 6 equal-sized sections. That means you should have 6 answers in your sample space, which I do. I've got 1, 2, 3, 4, 5, 6. So it matches. It makes sense. If you only have 5, then you know you're missing an answer. Maybe you only had 4, you know you're missing something. So here's part A, the sample space. Part B, this time I wanted to know what are the probabilities of each outcome in the sample space. Probability of 3. We're also going to have probability of 4. Now what makes this problem different? Notice guys, I've only got 4 probabilities wrote down for part B. Whereas on part A, I had 6 different things. The difference is, if I want the probability for a 1, it doesn't matter which one I spin on. I could spin on this top one, I could spin the bottom one, or I could even spin on this one that's on the left-hand side. But as long as I spin on a 1, I have fulfilled that prediction, or I've fulfilled that probability. So in sample space, we're going to include all the options. We're finding the probability. It doesn't necessarily matter which one, no pun intended, or which one you spin on. So my total goes on the bottom. So what is my total here? Well, my total is 6. You could land on any of these 6 sides, or these 6 sections. How many ones do I have? We'll go through and count them. You have 3 ones. So my fraction is 3/6. You can simplify that down to 1/2. Turn it into percent, 50%. Guys, whenever it says on part B here, what are the probabilities, you need to take these down to at least the lowest fraction. I would really appreciate it if you turn these into percentages, because when we talk probability, well, when you ask somebody, what's the probability this happens? Well, it's a 50% chance. Or maybe that someone might ask, what's the probability of it raining tomorrow? You might say, well, it's a 30% chance. We normally talk percentages when we hear probability. So you really need to get used to percents. Let's look at the second one. So I've got probability of landing on a 2. So my total didn't change. My total is still 6 because I still have 6 different sides on this spinner. How many of them are a 2? Well, 1 out of 6 are a 2. 1 out of 6 is as low as it can go. And then from there, guys, we would just need to divide. And we're going to divide 1 by 6, and that's going to give us a decimal, which we can convert into a so if you're not sure what 1 over 6 is, a couple ways. You can create your division bar, and you can put 1 on the inside, 6 on the outside, the number that's on top always goes in the inside, the number on the bottom always goes on the outside. Or you can take your calculator, you can type in on it 1 divided by 6, and that's going to give you 0.16, and that just keeps on going. Move your decimal 2 spots, 1, 2. So this is going to be equal to 16.6%, or 16.7%, just kind of based on how you round. Let's look at number 3. So number 3 is going to be very similar. Again, something over something. Well, the bottom is always your total. I've got 6 different pieces. How many of them are 3? One of them is a 3. So again, I'm with this 1 over 6. So that's actually the exact same percent. Maybe you had it at 16.7. I guess if you round, that's actually going to be a better answer. 16.7%. Last one, number 4. So again, something over something. 6 pieces. 6 is my total. How many of them are 4? Only one of them is. If you look at your spinner, it's right there. So again, I have this 1 over 6, which is 16%. So there you have it. There's the answer to number 6. Notice, guys, sample space is larger than what we did on part B. Okay? Let's go ahead and let's look at question number 7. So number 7, it says Heath records the number of winners of 3 ring toss games in the table below. So for game 1, it looks like 123 people played, 52 won. Game 2, 155 people played, 63 won. And on game 3, there were 172 people that played and 65 winners. Based on the data recorded in the table, how many winners should Heath expect if there are 750 players? Now, guys, I will say this is a question that I'm not a huge fan on, and the reason I'm not a big fan of it is because this question does not necessarily specify, okay, did 750 people play all 3 games, or did 750 people play just game 1? Or maybe they played just game 3. All it says is, based on the data recorded in the table, how many winners should Heath expect if there are 750 people? Now, because the question says, based on the data recorded in the table, I'm assuming they're talking about the entire table. So we're going to just imply that this 750 players means for the entire table for part 7. So how can we do this, and how can we find about how many people there are? So if I was you, again, if we're doing probability here, I have a fraction. And that fraction is going to be something over something. Well, the denominator is always going to be your total. So it's going to be my total number of players. So what do you think your top answer is going to be? Well, let's put it this way. What if I had a game where 2 people played and I had 1 winner? Well, the probability of winners would be 1 over 2. Well, what was that went in my numerator? That is my winners. So winners, the number of winners that you have, is going to be your numerator. This is the number of, your total number of winners. So because we're using this entire table and we're using this entire chart that they give us, we need to go through and find the total number of players that there were, and the total number of winners that there were. So I'm going to grab my calculator, and I'm going to kind of write this one out. So if you add up all of the people that played this game, 123 plus 155 plus 172, you end up with 450 people that played games 1, 2, and 3. Then you go through and you add up your winners. So 52 plus 63 plus 65. Whoops. 52 plus 63 plus 65. You get 180. So I had 180 people win out of 450 people that played the game. I want to know about how many win if 750 people play. To solve, we can set up a proportion. So I've got the winners over the total. Well, what if my total is 750? I want to know how many winners there are. Since I don't know, I can label that with an X. I set these two equal to one another, and then I can solve through a proportion. So I can cross multiply whenever we solve through a proportion. So 450 times X. And that equal to, again, probably going to need my calculator on this one, 180 times 750. And that's going to be equal to 135,000. Get a 0. Last step. I need to then divide by 450. So I divide X. Remember, X stands for how many winners out of 750. So if I take that 135,000, and I divide it by 450, it's going to give me 300. So about how many winners were there? There was about 300 winners. So we could put that in our answer then. And we want to make sure we show that because that's really what it is. It's more of an estimation. It would be about 300 winners. So there you have it. There's your answer to number 7. Again, not a big fan of this one because it doesn't necessarily say what we're comparing it to. Because guys, if we were comparing this just to game 1, this would be a totally different problem because in my proportion, I wouldn't have had to add all these numbers up. I would have just had 52 over 123. And that's going to make this 300 a different number. So again, we're not really, I think what they're asking for is this entire table. And if that is the case, then we did set it up right. Make sure that you kind of understand with probability, it's going to be whatever your favorable outcome is, which in this case, it's going to be your winners out of the total number of players. So the total or how many in all, really. All right, let's go ahead and let's move forward. We got 2 questions left. So we've got number 8 and number 9. Let's look at number 8. So on number 8, it says here 4 people entered their names into a drawing. The winner receives one of 2 different prizes that are randomly selected. The tree diagram represents all possible outcomes. So it looks like the 4 people that played were Rob, Sonia, Jack, and just says A and G. Not really sure how to say that. I guess we'll call that one Angie maybe. And their prizes then were a t-shirt or a mug. So 4 people, they had a possibility of one of 2 prizes. So if Rob won, he could have got the t-shirt or the mug. Sonia won, t-shirt or the mug. And same for Jack and Angie. So part A, what is the probability that Angie wins and is given a mug? So again, if I'm looking at probability here, well first, what's the probability that Angie wins? Well, the probability that Angie wins, guys, there's 4 people. Angie's one of them. It's like if I had 4 names in a hat and I pick one of those out. Well, that probability would be 1. This is not the answer, by the way. Your probability would be 1/4 because Angie's one of those 4 people. Your probability would be 1/4 or 25%. So notice, guys, I took this first line in my tree diagram, that was my denominator, 1, 2, 3, 4. Angie was one of them, so that was where my numerator came out to be just 1. Well, my question asks, what is the probability that Angie wins a mug? Well, let's look at that line of the tree diagram. How many options do we have here? We have 1, 2, because we have t-shirt mug for Rob, so that's 2. We have t-shirt mug for Sonia, so there's 3, 4. We have t-shirt mug for Jack, that's going to be 5, 6. And we also have t-shirt mug for Angie, so 7, 8. So the total number of outcomes, my denominator is going to be 8. What is the probability that Angie wins and is given a mug? Well, how many of these outcomes have an outcome of Angie and a mug? Well, that would be Angie, mug. There's only one of those. My probability is going to be 1 over 8. Again, we can find that the percentage by doing 1 divided by 8. That's going to give me 0.125. You move the decimal 2 spots to the right to 12.5%. And there you have it. There's the probability that Angie wins and is given a mug. Let's look at part B. So for part B, what is the probability change if the prize were chosen first? So this time, guys, the prize is chosen first. How is that going to be different from the previous tree diagram that were provided? The first tree diagram, guys, it showed the person was chosen first and then the prize. The second time they're asking for it here in part B, the prize is chosen first. So let's create a new tree diagram that's going to show this. So on this tree diagram, if I do the prize first, there's 2 prizes. The prizes are going to be a mug or a t-shirt. Okay. If a mug is chosen, then I ask myself, who are the people that could win the mug? And that would be Rob, Sonia, Jack, or Annie. If I had the t-shirt, how many people could win the t-shirt? It could be Rob, Sonia, Jack, or Angie. So I've got my new tree diagram where this time the prize is in the first row. So how is my probability going to change? So that's how many outcomes I have in my tree diagram. So if I add them up, 1, 2, 3, 4, 5, 6, 7, 8. So it's still 8. What's my numerator? So where am I seeing Angie in a mug? Well, the only spot I see Angie in a mug is in this one spot. So 1 is still going to be the numerator. So will the probability change? The answer is no. The probability will not change. And guys, the reason is really just because the tree diagram really just kind of flipped. Notice that my tree diagram that I have is really just kind of the reverse of what we have at the top on number 8. So not really a whole lot of change. I still have 8 different outcomes, which is where my denominator is. One of them is a mug with Angie, so therefore still going to be 1 over 8. Let's go ahead and let's jump into number 9. We've got a multiple choice question here, so this one should be pretty good. If you ask the probability of getting this one right, you got a 1 in 4 chance because 1 right answer, 4 total options. There you go, mixing probability into this one a little bit. Number 9. A probability model includes the probability of a 1 is equal to 3/10. I'm going to write that down. I think that could be helpful. And the probability of a 2 is equal to 1/5. Which of the following probabilities could complete the model? Now, something guys, that I noticed without any knowledge on this question, and maybe you're completely confused and lost on it, something that I want to get the same, because right off the bat, I can tell that something's not right here. I want to get my fractions where they're the exact same. One has a 10 in the denominator, the other one has a 5 in the denominator. I want to get them where they have like bases. So I'm going to change it where I have 10 as a common denominator. So 1/5 into 10. 5 times 2 is 10, so 1 times 2 is 2. So the probability of a 1 is 3 over 10. The probability of a 2 is 2 over 10. Well, notice, guys, 3 and 2 make 5. And if we kept it as a fraction, it'd be 5 over 10. So between numbers 1 and 2, we have 5 over 10. I want to get to 10 over 10. So how many away from 10 over 10 am I? Well, 10 over 10 minus 5 over 10. That's going to be equal to 5 over 10. So I know based on my options here, I'm looking at the probability of 3. Well, the probability of 3 has to be equal to 5 over 10. And that's because 3 plus 2 plus 5 equals 10. And 10 is my denominator, and I cannot have more than 10 pieces. So I'll 3, 2, 5, 10. 10 over 10. So my only answer is going to be, well, if I look at my answers A, B, C, and D, none of them really match, and that's because we need to simplify. 5 over 10, it simplifies into 1/2. So your answer on number 9 is going to be letter B. I hope you enjoyed the video. I hope you have a good understanding on this lesson and with this whole entire chapter as a whole. Again, you got a test tomorrow, so if you are unsure about anything, reach out, email me, ask me a question, tell me what you think, tell me what maybe you're having some trouble on, okay? Again, test tomorrow, study up, get a good night's sleep. Hope you guys are doing good. See you guys.